Testing audio. 1, 2, 3. Sounds like we are live. So I think we can begin. Ladies and gentlemen, welcome to the stream of the Discourager of Hesitancy. We are going to learn a new language today, and probably tomorrow. We'll work through some old Advent of Code puzzles, and we're going to learn NIM. We're going to get some links. How good is the documentation? I mostly care about the feature overview side of things. How easy to get Hello World running. I gotta get this just a second. Never mind, someone beat me to it. Hello World. How good is the Emacs mode? An Advent of Code. You have to pick a year. Work through a few puzzles. So we're not going to do Zig. There we go. That's our notes lined out. So step 1, we need to close a lot of tabs over here. We got too many tabs open. Oops, that was one I wanted to keep. All right, let's do this. TV. I can't show the screen unless I am in the right place. There we go. Okay. So we're going to share the browser, which now comes up. We type in NIM language. And there is our first link. All right, NIM. Oh, and we've already ruined it. I can't move my mouse when I'm sharing my browser, or else OBS loses my mouse. So. Stop sharing, bring it back. Okay, here we go. Oh, simple example. I don't like the word let. Blah, blah, blah. Surely there's a features. That's probably what we want. Oh, I don't want a package manager. Oh, and we did it again, didn't we? Lost my mouse cursor. Hey, G Finelli, how's it going? There we go. Let's see. I want to lose my mouse cursors. I can't. There we go. Now my mouse is back. All right. Looking at NIM today. We're going to scan through indentation, significant syntax, multiple constructs inspired by Python, multi-line lambdas, Ada, and modula. I'm not sure I'm going to much care for NIM here. Going good, good, good. Yep, New Year's all underway. We're 2 days in. We'll do a day or two of NIM. That'll wrap up this week. We'll figure out what we're doing a little bit more consistently later. All right. So this is going to be quite a bit different from Zig and Odin. NIM includes a first-class JavaScript backend, so you can target the client and server. See, this is not systems in language, is it? Small core with a rich prospect for extensibility. Macros. C, C++, and Objective-C wrapping. NIM is okay, I just don't like the lack of terminators like semicolon. Yeah, it says it's a white space sensitive language, so it's like Python or YAML, which I'm not a huge fan of. Helpful trace backs inspired by Python. Will output a stack trace before terminating. That's good, because I was not impressed with Zig's error messages. Well, not gonna lie, their features page sucks. Usually that's the place where you get the meat and potatoes. 5-minute guided tour through NIM, basics. Oh, we don't even have to have it installed. Official tutorials. NIM for C programmers. Standard library language manual. Tools. Okay, so maybe this documentation is better. Okay. Really bare bones in some of its pages. Yeah, let's just go try a 5-minute thing. Formerly Nimrod. Static type imperative programming language gives you the programmer power without compromises on runtime efficiency. On comments. They are nestable. Discard. It's interesting. Declare and assign variables with or without type annotation. So it has some, so this is like Zig syntax, not like Odin syntax. Let, declare and bind variables once. Yeah, so this is your constants. Or your pound define values. Computed at compile time. Yep. when is a compile time if. So this is like Odin. Odin stole this from Nim or vice versa. Let's see here. Nim. Okay, let's see. Is there a wiki page? Let's see here. First appeared 2008. So if we go to Odin programming language. Is there not a wiki page? Wikipedia page? Surely. No. I want to disambiguate this one. There we go. Oh, military places. Huh. When was its first release? Good heavens. All right, people. Not helpful. 79 releases. What's the first release? Boom. 2404. Tags. I want the releases. I don't want last month. I want the oldest one. Let's call it a 1.0. Is that the most official, probably? Changed his numbering scheme. 13, 11. Has he not released a 1.0? Surely. And call 9. There's not a date. March 3rd, 2017. So yeah, Odin probably borrowed from Nim with the when as your compile time if. Discard. Okay. Tuples. Field names and order. Yep. Positional, just like Python. Odin doesn't have 1.0. It's at 113 right now. Okay. I wonder what people's objection to putting things at 1.0 is. Oh well. Assign all at once with the literals. Today.sun. Or by index. Cool. It's good to have both index and named if it's positional. Yeah, they don't follow normal numbering anymore. It doesn't look like it. Imposter Rudiger 2. Heyo, Elside Congru. Hope it's going well. So far, so good. We're looking at Nim today. This is not the kind of language I would usually take for a test drive, but we'll do it anyways. Got a little more sleep. Got some healthier food in me. I'm still eating candy, but you know. We'll fix all that later. Same type and same content. So this inferred that it wanted a child and not today, because the types are different. I can see that being a little bit dangerous. No, no. Okay, so any tuple is like a Python tuple. Got it. It's a nice niche language, just like Zig, Odin, and the like. Yeah. Okay. So we're looking at sequences. Use at for a vector, so that's like Python, or not Perl. Perl, right? Add milk, so your sequences are all like the Python list. I do prefer Odin over Nim, yeah. Okay, defining types. Name, age, person. You prefer Zig over both? Lack of semicolon terminators bothers me way too much. Yeah, I don't know. So far, I think Odin is winning in my book for my preferences, but I can see where Zig might work well for people. But it's not because of the semicolons. Like, if Odin put the semicolons in and let some more normal syntax happen, I might like it better. But that's more of a preference thing. And again, for Zig and Odin, neither of them is so far off that I wouldn't be willing to use them in a professional setting. Like if somebody's like, "Oh, we're doing this project, we're using Nim or Zig," I'd be like, okay. Like I would take time for the syntax to sink in and become natural. But yeah. Odin is higher level, is closer to C++, and Zig is pure C. Yeah, maybe. I don't know. Zig does feel a little lower level. I don't think I'd put Odin in the C++ bucket, though. C++ is nuts. Person equals a tuple. Another syntax. Okay. Interesting variable. John equals a person. These are just type defs. Okay. Distinct int makes a new type incompatible with its base type. Yeah, so you couldn't pass an integer. You would have to pass cache. The casting syntax is a little bit interesting. Money. Same thing here. Okay. So a room is a reference to an object. Closer to Python than C++, but still nice. Yeah, yeah. Okay. Default house, default room, Sesame house. Okay. Enumerations. I'm not sure how I want to deal with enumerations in my language. The ability to get an enumeration value as an integer and its name as a string are all useful. But do you then want to have like built-in automatic typing to get it to an integer or to take an integer? Because I do that a lot. I'll use an enumeration and then I'll get the integer value. I have to cast it to an integer. But sometimes you want to not take an integer unless somebody really means it. I don't know. There's a lot of different versions and flavors of enumerations that make it a little tricky. Enums are usually an ordinal type. Range. Okay, so this is more like Ada, where you specify die faces can only have values in this range at all. That's runtime checked. Okay. I have to think about that. An array, fixed length, and indexed by an ordinal type. So that's a range, I think. Oh. Not sure I understand this. Oh, index. That's the index? I don't think I understand this 42.44 here. The counter makes sense. For each die face, you have an integer. For each direction, you would have a string. I have 3 truths between 42 and 44. But I can only index them by 42 to 44. That's interesting. I don't know why I would use that 99% of the time. Let me think about that one for a second. directions. Okay. This is almost more like let's see here. I do like their range-based for loops to provide the element and the iteration. Also, I like how easy it is to define a struct with a type keyword. I just don't like automatic type deduction. It makes me so confused coming back to the code. It seems easy to do that in this language. Yeah, I don't know. Range-based for loops are fine, but I think every language more or less does them nowadays. But yeah, type deductions. I think type inferencing is good as long as your editor can reasonably tell you what type things are. Then you're typing less symbols, but you can always access that value. Another array. Okay. Table set list queue and crit bit trees. Collections and algorithms. IO and control flow. Echo is print. So that's straight out of Bash. Case. Read line of standard in. No or no. Yes or yes. Otherwise, that's the default. So switching on strings, I kind of like, but I don't know if they're efficient about it. I have done the thinking. As long as it's a compile time literal here, I think we can do the most efficient possible string checking. That's different. Definitely use auto when the type gets complicated, but I just like seeing the type immediately when reading the code. So I guess, and that's one thing I like is when a variable is declared, I like to see the declaration, but when you're using it, so for example, inside of a range-based for loop, like 99% of the time, I don't care if it's a pointer to a thing or the thing itself. It's like, look, just yeah, tell me what it is. This is an element of that thing. I don't want the details at this point. When you're accessing an element, for example, most of the time. It does also make refactoring a little easier the less actual types you type. If you need to change a type, you can do it in fewer places, but I don't know. I mean, there's a reason I use Python as a prototyping language. If I'm trying to work through an idea, a lot of times I'll go to Python and just work it out because then I'm not thinking about types. I'm not worrying about memory. I'm not worrying about performance. Just get it working. So there's some room for that. And maybe the problem is different needs, different languages. Import output. Let variables, well, guess is not equal to number. Read a line. Skip empty strings. Parse int. We know we're probably going to use that quite a bit. Guess equals 1001. It's greater than number, too high, too low, otherwise yeehaw. Then it breaks. For index element, yeah, so it wouldn't have this too, although it reversed it, it has element then index if you include that, which is a little bit odd. Key values. Echo. Let my string an example string to play with, multi-line raw string. So this uses the Python triple quotes. Split lines. Okay. Hopefully that works with Windows line endings. For index and C in my string. It's using colons like Python. So yeah, this is a little bit more Python-esque. But you can put things on the same line, which is nice. Answer A enum, AS a no. Proc, ask question is type string. The answer is doesn't return anything. Okay. So you need colon and type for return. That's consistent. I could use see the use cases for it, but I still prefer being explicit generally. Yeah. Well, for larger projects, the larger the project gets, the more explicit I want it to be, because I can't hold as much of the program in my head. So the instant I look at it, I should know everything I need to know about it. For small prototypes, it's like, yeah, I don't care. I can always, hash it together, figure it out. It's small. The bigger the project, the more explicit I want it to be. Yes. Let's ask, would you like sugar in your tea? Looking for else, leave yes and no are possible. Because nim compiles to C. Okay. Okay. Easy to read, high performance code. Let's see. Let's go back real quick. Let's get the playground, the basics tutorial. We don't need to install it. So we should just be able to do that. And go Control Enter. That took a while. That did indeed take a while. C-R. If you're using VS Code, no. Yeah, I like the online compiler. It's a little bit slow, but the fact that I don't have to install it to try it is nice. I don't like cluttering my machine with a bunch of install things that I'm never going to use again, although I do. But it does take long enough. I may just go ahead and install Nim at this point. Let's download it. 64-bit, absolutely. Downloads. Yeah, so try the online compiler if you don't know if you want to try it or not. Nim has been extracted. Bin nim.exe. So this is what I want to add to my path. Let me add this to my path real quick. Environment variable system path edit. Okay. All right, let's try this then. We're gonna go stop showing the browser briefly. I'm gonna reload my Emacs so we get the latest path variable in the environment. Nim, hello world, main.nim. That is a program. Nim c-r main.nim. Uh-oh, they were doing so well. Using config file. Identifier function. That's that prefix underscore in main. std sync.io. gcc-c-w. Um, Environment, always a problem. Why is environment so hard? Nim, Windows, GCC, O binary. Okay, somebody else has this problem. I guess I should show the browser for that then. Done. Here we are. This is back in 2020. There's like a theme here of me running into things in both Zig and Odin and Nim now. We're all complained about back in 2020 that are still a problem. Yeah, so it's the different GCC compilers, but Sigwin is not supported. Unbelievable. Oh, hey, Choppers13. Thanks for the follow. Appreciate it. How's it going? Welcome to the stream. We're trying to get Nim running, but of course we run in a MingW supported environment, and it seems to not want to do it that way. If I change the order of my path variable, would that help? Sigwin not supported. MingW support. Compiler user guide. Let's see. All right. Oh, so I should be able to run with MingW. So let's see. Let's go to browser. Which GCC comes up first? Hmm. User bin GCC. See, it doesn't exist, so. Let me check my environment variable. I have multiple things installed at different places, so. Let me see, what I got? Environment variables. Path. What if I change the order? Of my variables. Let's bring it back up. Nim notes. Doesn't work. Which GCC? Yeah, still comes back to the same one. Can I not point nim to a different GCC? Surely there's a way to do this, right? Which bash? I mean, it's the MSys one, right? Which so name itself is just a transpiler, anyways. In the default use case. This is probably what I want. Cross compilation. Blah blah blah. Dash D, I mean W. Okay, so I'm going to play through things out of this page. Compiler selection. So that might be a thing that we can actually do. Let's go back to here. Nim C -R, and we will use main.nim. That will fix it. But in theory, nim config. Nope. The system cannot find the file specified. That fails for the same reasons. So let's look at our files here. This is our nim config. Okay, so what if we replace this with something we use elsewhere? So let's see here. The do active projects word sleuth source make file. I set the compiler there. I'm gonna try that. What's the other one? Config.yams. We're gonna take a look at that. Yeah, don't care about that. Okay. Now we're gonna try this one again. Unknown C compiler C. Has to be a known one. Maybe we point it to Clang? Do I have Clang installed? I don't remember. Might have Clang installed somewhere. I might not have Clang installed. Cross compiling. Ugh, I hate to be the person who had to work out all this configuration nonsense. Hey, Dravest, good afternoon. How am I today? So far, so good. New Year's was good. I ate too much. Definitely was not wide awake yesterday on the stream. Short stream. Today, we're back to normal. So we're trying to figure out NIM. It has some environment issues because of the way I have my environment, which is a little on the unfortunate side. But we will try to figure it out. Options. Yeah, it won't let me just point to the GCC that I want. And because of this bash, oh, here we go. Maybe this is what I need to set my GCC path. Find the file. Clang. Why is it still playing for Clang? Oops. Come back. Okay. Exceptions.nim. Indication of external compiler program failed. Cannot find the file. This can't be. Oh. If we put our path in the right place. Okay. Hello world. We got it. Okay, so let's go to our notes. Documentation. Features wasn't a good place to start. Better if you start at, let me dig up the link. Where did I put it? Let's see here, documentation. And where do we actually go? The 5 minutes tour wasn't. The 5-minute tour was okay. Should try the NIM for C programmers guide to see how that goes. Okay, so documentation isn't bad. Installation. Let's see here. Download. Unzip. Requires GCC. Wrong GCC in my path. So I had to modify config to point to the right one with the line. then it worked fine. Okay, so environment variable issues, but not too bad. The fact that GCC path wasn't clearly documented right off the bat, because I have so many GCCs installed. Like, that's fine though. It's fine. Not too bad. So let's call that a 8 out of 10. It's not bad. This one, I'm gonna withhold judgment for just a little bit while we look at the C programmers. I always go to a feature list first. That's almost always where I get the good overview of the language features. So a little bit weird there. Hello world. 10 out of 10. Just because I can install it doesn't mean it doesn't work. So okay. Online compiler provided to play in a sandbox without installing or and fighting environment issues. So yeah, 10 out of 10 on that. Once GCC was pointed to nim or compiled and ran hello world, just fine. Emacs mode. Oh, we need to get an Emacs mode. So all right, we need an Emacs mode. Let's go grab one of those. How was your New Year's, Dravest? Any good projects coming up for the year? I'm gonna go dig up an Emacs mode. Nim lang Emacs mode. Here's a mode. Oh god. Okay, let me show you what I'm looking at here. We already know my preferences for not having dependencies, so what the heck is this? This better have all the dependencies in it. All of them. Nim mode L. That's probably the one we want. Where's the download button? Sure, there's a download button. Mode. I don't want to do a git. I'll do a git pull if I have to. Okay, let's go see if we can do this. C colon users Emacs. Really? Oh, do I remember where I put these things? Get clone Emacs. Code in for Nim. And this is in Nim mode. I think that's how that has to go. If we made a mistake, we'll find out shortly. Reload. It says some fundamental mode still. File missing, cannot open load file in such file or directory nim mode. Huh. My Emacs directory. It's there. Hmm. Commenter. It does all that code in there, and it doesn't just have commenter. Have you figured out which system's level coding language you like yet? Oh, let's see here. Let me back up. Oh, doing good, C Films. How are you doing? How are you doing? No, I'm Odin, Zig, Rust all have things I like and things I don't like. So far, Odin is the one I like best of them, of the three. But it has its definite complaints. We're trying out Nim today. Right now I've got it basically ranked Odin, Zig. I'm not sure about Nim. Rust is not really on my list of languages I want to play with more. I could work happily in Odin or Zig and not be too whiny about it. Like there would be, you get used to the syntax and the way of thinking about the language. It's not that far off that I would hate it. So yeah. So far I'd still probably go C with a little bit of C++ on top to get operator overloading and function overloading. So yeah, probably C, C++, then Odin, then Zig. I'm not sure about Nim yet. I'm still playing with it. Yeah, C, C++, then Odin, then Zig. Commenter. Commenter. Specification error cannot open load file. Commenter. So Nim is losing ground here due to. Do I have to try to install it? I don't like having to use package install Nim mode. I'm not sure I have Melpa installed and running anyways. Contacting host, install package, Nim mode. Really, no match. No public key. Yeah, I don't really use Melpa. That's one of the things we may have to look into. Nim mode commenter Emacs. package requires shoot. Yeah, lots of dependencies. Yuck, yuck, yuck. So we might be doing nim without a nim mode. Yeah, so nim is like this interesting, it's got a bit of Python feel to it, but strongly typed with some other ideas out of like Ada, and it's kind of an interesting language, perhaps the most different of the ones we've looked at so far. Both Odin and Zig have a strong C flavor. Okay, so we're losing ground here. So let's hear notes. Emacs mode. Question mark out of 10. We'll come back and look at the C programmer's guide. Emacs mode. Emacs mode has a ton of stuff in the download, but also doesn't just work as is, has dependencies on other packages that aren't in it. The download itself. Pretty much have to use Melpa, which I don't. No, that's sad. That's going to be a bit of a stumbling block for us. We're going to go back and take a look at the C Programmer's Guide just to see how their translation is between what's going on. We did figure that out. We did figure that out. We did that. I don't need. List of releases. Okay. So we're going to go to this and show nim for C programmers. I'm also a Python programmer. We'll see. Comparison. Oh, disclaimers. Hidden disclaimers. Unofficial work in progress. Okay. All right. Machine code via C. Yeah, so nim is a transpiler. It transpiles to C. It has templating and macros, garbage collector or manual. Okay, static typing, dependent types, generics, standard integer types, arrays, characters, enumerations, anonymous functions. Yeah, C++11. Inferencing. Ooh, custom operators. I've played with this idea for my own language, not sure if I want it, but because there's a couple of interesting things that could happen, but I honestly don't know how it makes a compiler work with custom operators. Because you have unary and binary operators. collisions with other possible operator, syntax. I don't know, lots of different things that can happen there. This is true. I have written a polymorphic random number generator, my own V table, all of that in C. And it worked fine, so he is correct. Methods, multi-methods, exceptions. I don't like package managers, file extensions, arrays. The C code will compile, may or may not crash. The new code will not compile because it's a bounce checking at compile time, which is fine. Yeah, so it's basically got a few more checks than C does. Unsigned integer, object orientation. Okay. More powerful than C structs, but don't behave like C++ objects. Inheritance, but not multiple inheritance. Okay, so single inheritance. There's no implicit this or self. Structs and tuples, yeah, we talked about that. Cheat sheet. Multi-line comments, maybe nested. I always like that. I'm surprised that C++ still doesn't have it, but okay. Count defines, yep, instead of when. Strings are passed by value. Okay, and strictly bounce checked. Oh, they use mod instead of %sign. Oh, unsigned numbers. That's truly bizarre, but okay. So I'll have to remember that if I do a modulus operation. Echo byte. Yes, so this uses the old just string together a bunch of junk. You can't use \n as a character literal, as it expands to CRLF. Thus, you need to specify which character to use. Oh, interesting. Huh. See, why are we still fighting the Windows CRLF? If returns the value of the expression they evaluated. Yeah. So basically the last expression of an if statement is returned as the result. That's like Lisp. Functions, procedures, blah, 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 yada, yada, yada. Dereference. The name of the string is also copied, but references are not deep copied. B equals A brackets. which is the dereference, I guess. So A, empty brackets is dereference. I'm not sure I like that, but okay. You want to create a systems level load coding language? Yep. Basically, it'll be a fairly normal C base for the language, but we're going to do some other things with it. That's a long ways out, though. Especially since I'm really dedicating enough time onto the compiler time anyways. Like 1 day a week is not enough, and we're doing some bizarro things. We're getting to push down finite automatas. The ALR parser generator won't be too bad. I've already built parts of it, so we can copy paste good chunks of it. We won't require you to use the LALR parser generator, but it'll be there for me to use if I want it. Simple casting dot whatever. Okay. Try the one for Python. I do Python too. Whoa. This is a much beefier. I'm confused. Oh, that's with Python. This is with. I gotcha. This is not how I'd write this anyways in Python. I'd wrap this in parentheses. Not stripped up parts, yeah. So it's a little bit more convenient than Python in some ways. Consistent spacings. Oh. Scoping. Error in the declared identifier X, yeah, so it does better job scoping than Python. Python just has a runtime environment that doesn't always clean up things properly when you leave a scope. Okay, blah, blah, blah. Boolean conditionals. Do I care about some of this stuff? Block. The word block. Example. So it creates a scope. My development progress on flag coding language is slow. Yeah, making a language is hard. It's a big project. It's huge. You were doing semicolons, if I remember right. I was working with some caveats or some cases you were working around. Block. Mutable arguments. That's how you tell it mutability? I don't like that syntax at all. Do I? Oh, it's an array of 0, append 42. Oh. Imports. There's more stuff in the Python stuff, but honestly, as a language, you can use import from the compile command. Oh, I've gotten stuck on semicolon and variables. Well, It can be tricky. You need a right now you're a runtime language. You're not a compiled language, so and you're writing it in Python, so you probably need a dictionary of variables and look up existence of variables, but you have to be able to detect when you type something if it's a keyword or a variable. Fun times. So many corner cases you don't think about until you try to build your own language. That's why you should build your own language, right? You start learning how the world really works. Very enlightening. All right. I'm going to say it's fine. It's fine. Vim for C or Python programmers. That does a lot of things. The C one is a bit thin. The Python one is a 900-pound gorilla. Really, Vim isn't as much like Python as they want you to think, other than the white space scoping. Um, Tons of code snippets available in the documentations to start copy pasting. Documentation is okay. Installation execution was. What did I say for Zig? Zig notes. Installation. Yeah, Zig was just super easy. Notes on Odin. Odin took me a little work. Hello world. Okay, so this was better than that. Yes. No, not that one. It was like a 5 or 6. It was better than the Odin installation, but worse than the Zig installation. So about the middle. Okay, hello world. Worked great. Blah, blah, blah. Emacs mode. Yeah, that's kind of zero. All right, so I think we're just going to start in on an advent of code. And start using them, right? You can only start documentation for so long. You try to get an idea of the flavor and some of the basic syntax ideas. I think we're past that. We can just jump in. So we're not doing 2020. We need to pick a different one. So let's go choose our year. I'm do an old one. Should we do 2021? Or we could do 2018. Let's do 2021 and see what happens. Sonar Suite. Okay. Let's get started. Let's just start coding with this. We've done enough reading. Let me copy this into a prompt text. Nim, advent of code 2021, day 1, prompt. We need our input text, which we're going to go grab real quick. And we can get the small test. So let's see here. Let's just get this lined up so you can all see on this screen size. Okay. You're minding your own business on a ship at sea. When the overboard alarm goes off, you rush to see if you can help. Apparently, one of the elves tripped and accidentally sent the sleigh keys flying into the ocean. Before you know it, you're inside a submarine. The elves keep ready for situations like this. It's covered in Christmas lights, because of course it is. And it even has an experimental antenna that should be able to track the keys if you can boost its signal strength high enough. There's a little meter that indicates the antenna's signal strength by displaying 0 to 50 stars. Your instincts tell you that in order to save Christmas, you'll need to get all 50 stars by December 25th. Sure. Collect stars by solving puzzles. 2 puzzles per day. Second puzzle is unlocked when you complete the first. Each puzzle grants 1 star. Good luck. As the submarine drops below the surface of the ocean, it automatically performs a sonar sweep of the nearby seafloor. On a small screen, the sonar sweep report. Each line is a measurement of the seafloor depth as the sweep looks further and further away from the submarine. For example, if you had the following report, which we are going to use as our test code, so input small.text. This report indicates that scanning outward from the submarine, the sonar sweep found depths of those things. The first order of business is to figure out how quickly the depth increases, just so you know what you're dealing with. You never know if the keys will get carried into deeper water by an ocean current or a fish or something, of course. To do this, count the number of times a depth measurement increases from the previous measurement. The changes are as follows. 199, 0, 200, increased, increased, increased. So there's some increase and some decrease. How many measurements are larger than the previous measurement in our input? That's this one. Woohoo! Okay. So in this case, the answer is 7. So we need to main.zig. Let's go. I don't know here. Nim. Oh, I named it zig, didn't I? Rename file and buffer. We're in nim today. What? Nim. Okay, whatever. Nim read file. We're just gonna see if they give us this here. Really it. Somehow I doubt it, but okay. Oh, the colon do active. Let's see here. Nim. Enter the code. nim c dash r main dot nim. Let's just start with an echo. Hello world. Yep, it worked. Input small. Seems to have worked. All right, nim string to int. This should not be hard. Let's see here. In string compare. I'm pretty sure it's just equal, right? Len. I can get the nth character using simple array stuff. Oh, you can go negative indexes. String assignment. Equals operator. Does work as expected. Good. Line equals this. If last value is less than 0, last value equals value. Otherwise, this is where having a mode would be nice. Otherwise, if increasing, so if the value is greater than the last value, incur count equals 0. Incur count plus equals 1. Let's see here. Does nim increment operator. Oh, you use the word int. Interesting. And at the end, echo increased depth incur count times. So should output 7. Did not work. Last value. Oh. Var. undeclared value. Increase depth 9 times, which is not right. Our input small increment, 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 decrement, increment, 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 decrement, increment. Echo modular value greater than last value, which is value greater than last value. Seven. There we go. We got it. Perfect. Now we just change our input. Actually, we can even count. Measurement count. Input measurement count. Out of mes count. Seven times out of 10. Let's run it over the big input now. $15.48. All right, let's go submit our answer. Boom. Which means I need to share the browser. Put in our puzzle input. We are correct. Part 2. Oh my, things get more complicated. Copy. Let's go put that in our prompt. Considering every single measurement isn't as useful as you expected, there's just too much noise in the data. Instead, consider sums of a 3-measurement sliding window. Yep. Again, considering the above example.
Okay.
All right. Bring the first and second 3-measurement windows. ABC. .607. The second window is marked B. 202.10. sum of measurements in the second window is larger than the sum of the first, so this first comparison increased. Okay. So we're just maintaining a sliding window of 3 sums, adding and subtracting as we advance. Okay. This is a little bit odd, but I don't think it'll be too bad. So we need to store 4 values or something. My brain is rebelling a little bit. Is this because it's not how you actually measure things, but okay, whatever. Sum 1 and sum 2. Then we need var value 1, value 2, value 3. We have to maintain 4 positions. Part B part. Value 1 equals our value. Value 2 equals value 1. Value 3 equals value 2. Do that. Oh, I don't think we have to maintain these 2 sums. We can just compute them here. Value 1 not equals greater than 0. I don't remember nim and. How is nim so far? That was not bad so far. Nim. Boolean and. Nim operators. Yeah, so nim is interesting, an odd combination of Python and systems language. Keywords as identifiers, string literals, character literals, numeric literals. Operators. These keywords are also operators. I think I use and. Value 2 greater than 0 and value 3 greater than 0. Value 1 equals value plus value 1 plus value 2. Sum 2 is value 1 plus value 2 plus value 3. If sum number 1 is greater than sum number 2, windowed increment count window depth when increment count think that might do it. Oh, let's see here. Someone we can prepare those. Oh, looks like we increased our depth more times, which kind of makes sense. If that's time for bed, all right, you have a good evening. We'll see you tomorrow morning. Or I have a meeting tomorrow. Yeah, meetings. All right, well, we'll see you tomorrow then. Okay, so we're going to try submitting this output into our advent here, 1589. That's the right answer. Cool. All right, that wasn't too bad. It lets me do string-based things very easily, perhaps too easily. It lets me convert strings to integers. That's not bad. That's not bad. This is pretty good. So let's do day 2. Where are we at? It's 2 o'clock. Day 2. We're diving for our keys. All right. Day 2. Prompt. Day 2 diagram. Now you need to figure out how the pilot this thing. We're in their little submarine to try and save our keys. Seems like the submarine can take a series of commands like forward 1, down 2, or up 3. Forward X increases the horizontal position by X units. Makes sense. Down X increases the depth by X units. Up X decreases the depth by X units. That all makes sense. Note that since you're on a submarine, down and up affect your depth, so they have the opposite result of what you might expect. That's fair. We're doing depth, we're not doing distance off vertical off the surface. So we're doing distance from surface, not distance from depth of sea. Yeah, you should probably figure out what it's going, where it's going. For example, forward 5, down 5, forward 8, up 3, down 8, forward 2. Your horizontal position and depth both start at 0. The steps above one, then we modify them as follows. After reading these instructions, you'd have a horizontal position of 15 and a depth of 10. Multiply these to make 150. Okay. Input small. Oops. Okay. So we need to follow the path and see where we end up. Easy enough. So I guess the real question here is, would I use nim over Python? I don't think I would use nim over C. Like the kinds of problems C solves, I don't think about in a nim-like way, but nim seems to be an okay, not replacement for Python maybe. It seems to be competing more on Python, but not as slow and more statically typed. So in that case, maybe I could use nim as a replacement for Python if I were to do anything with it. We're going to use string utils for each line in our input. We're going to split our line. Let's see here. Nim split line. Let's see. Split. R split, 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 split. String S. Separator is a character. Maximum split. Sure. And that gives me an array. All right, I think I can do this then. Var command equals this is in stir utils. Yep, so split our line by a comma. If I'm not doing comma, we're doing it by spaces. Our small input, yeah, it's by spaces. Then we do var operation equals command sub 0 var amount equals command sub 1. If we were to parse it into a string, let's see here. Parse int command part 1. Okay, then depth equals 0 var, what do they call it? The prompt. Horizontal position. Horizontal pose also equals 0. If op equals forward, down, and up. Pose plus equals amount, depth plus equals amount, depth minus equals amount. Oops, that's not a minus. There we go. Echo final position. H pose. How many commas? No, I've already forgotten. I do need commas. H pose, comma, depth, comma, parentheses, colon, depth times H pose, which is the answer. Make file. Okay, error. H pose undeclared. If that makes any sense. Attempting to call routine H pose. Make it a naming collision. Horizontal position. And 17. Comma. All right, we've got an error. Cannot open input.txt, which is fine because we don't have one. It's input small. $150. Final position came by 10. But I do need our input, which we'll have to put it in here. Just a moment. There it is. Final position is a big old number. Let's go submit that. Bonk. Here we go. Boom, it's the right answer. Woohoo! Part 2. All right, put this in and get going. See, I have to let go of the idea that nim, I have to let go a little bit of the idea that nim is a system language. It's It feels more Python-like in some ways. Based on your calculations, the planned course doesn't seem to make any sense. You find the submarine manual and discover that the process is actually slightly more complicated. In addition to horizontal position and depth, you'll also need to track a third value, aim, which also starts at 0. The commands also mean something else entirely different than you first thought. Down X increases your aim by X. Up X decreases your aim by X. Forward X does two things. It increases your horizontal position by X. It increases your depth by your aim by X. All right. Okay. Forward 5 adds 5 to your horizontal. Total 5 because your aim is 0. Your depth does not change. Down 5 adds 5 to your aim, resulting in 5. Forward 8 adds 8 to your horizontal position. Because your aim is 5, your depth increases by 8 times 5. Up 3, down 8. You would have a horizontal position of 15 and a depth of 60. Now we've got to do the same thing over. Okay. It doesn't look too bad. H pose 1, var depth 2 equals 0. H pose 2, and we need a var aim, which we're going to call 2. So if we say down, then our aim adds 5 to your aim. And minus, then H pose 2, and then our depth 2 plus equals depth by the aim times X. If we run this against our small input, I remember what we're doing this here. Dun, 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 error in aim. Two, two, and 2. 15 times 60. All right, I think we're good. In theory, it's this big number. All right, let's put it in. Try it out. Get our browser and submit. Hey, it's the right answer. Cool, we got 2 days done already. Nim isn't that bad. I'm not that complaining about it yet. A couple of like it's familiar enough because of its similarities. It's not too bad, not too bad. All right. Let's go do day number 3 then. Binary diagnostic. Okay, submarine has been making some odd creaking noises, so you have to produce a diagnostic report just in case. The diagnostic report consists of a list of binary numbers, which, when decoded properly, can tell you many useful things about the condition of the submarine. The first parameter to check is the power consumption. You need to use the binary numbers in the diagnostic report to generate two new binary numbers called the gamma rate and the epsilon rate. Power consumption can then be found by multiplying the gamma by the epsilon. Each bit in the gamma rate can be determined by finding the most common bit in the corresponding position of all numbers in the diagnostic report. Well, that's bizarre. Okay, the epsilon rate is calculated a similar way rather than the most common bit. The least common bit is used. Okay. Interesting. Let's go get our input. We got this for our small input. Well. They're not even the same length. So that's going to be a little bit interesting. We don't have to make this robust. So we could literally hard code the width. I think we really need parsing at this point. We're going to go for each line. Var total entries equals 0. Var 1 entries equals 0. Character in line character and index if C equals 1 entries or 5, right? Increment. Let's see what that does. Let's just see what this does. Hmm. Better bit count 7 ones, 5 ones. 5 and 7. Second most is 0. Just common to the third are 1, 1, and 0. So basically anything over 6, 1, 1, 0. So I think that's correct. Okay. And we should be able to, what's it called? Where you add up the binary numbers. To get there. Or count in 1 entries entries. Correct. Okay. For value in gamma and epsilon For V in 1 entries, so if we have more ones than zeros, if V is greater than total entries minus V, hey JTL, NIM so far is pretty good. It's fine. It's syntax-wise more like Python while still being strongly typed, but with enough type inferencing that you don't have to think about the typing too far. So far, it has good built-in support for strings and files. It hasn't blown up on too many things that we've gotten bitten by in the last little bit. The Emacs mode I did not like. It's not coming in without going through some hoops. More hoops than I care to fight through, so that's unfortunate. But yeah. So it's a 1, gamma equals gamma times 2 plus 1, epsilon equals epsilon times 2, otherwise, basically the other way around. Gamma epsilon what did the prompt call it? Binary power consumption. Power gamma times epsilon. Yeah. Any Visual Studio dependencies? Nope. It was pretty simple to set up. We had to change the path to our GCC compiler, but once we did that, it was fine, and it used the one that we had. So it wins out over Odin for ease of setup, but not as good as Zig. So that's kind of the bottom line. I didn't have to fiddle too much with it. Okay, gamma 22 epsilon 9. We did not put a space in there, which we should have done. Let's compare that to our prompt. So the gamma rate is 22. I don't think that's what I got. I did get 22 for gamma. And the epsilon was 9 in decimal, multiplying the gamma rate by the epsilon rate reveals 198. So I think we are right. So what we've done, let's go look at it, is we went through this file, input small, and we summed up the bits going down and counted, is there more ones or zeros in that column? And then if it's more ones, then we count it as a 1, and we add that to gamma. So this is converting a binary into a decimal for us. And epsilon is the opposite. You take the least common bit in that column. So this is, what's it called? There's a simple algorithm for converting binary to decimal. Binary to decimal, what is it, like Dibble Dell or something? It's a is it called? Nobody ever does it, really. That's a bold, bold assertion on the internet. Look at that. You never need to change decimal to binary or decimal binary to decimal. Nobody ever does it. Huh. Well, that's just stupid. Who said that? What a moron. I just did it. Absolutely unbelievable. I just did it out of my head. Anyway. So this is the correct answer. So let's run it against the big one. So this is 5 bits. The big one I know has 12. So 5, 10, 11, 12. We'll run it against the big one. Okay, gamma whatever, epsilon whatever, we have a huge power consumption, which we submit. Right here. So the short answer is Santa Claus's elves dropped the keys of the submarine off the edge into the deep, and so we're using sonar and trying to drive our submarine to go save the keys. Otherwise, we'll have to cancel Christmas. Oh, oh good heavens. Copy. We're gonna have to look through that. Good heavens. That's a bit of an extension of our problem. Prompt text. Part 2. We should verify all sorts of things, apparently. Yeah, it's gonna take so part 2, you should verify the life support rating, which can be determined by multiplying the oxygen generator rating by the CO2 scrubber rating. Our values can be found in your diagnostic report. Finding them is the tricky part. Both values are located using a similar process that involves filtering out values until only one remains. Oh, geez. Before searching for either rating value, start with a full list of binary numbers from your diagnostic report and consider just the first bit of those numbers. Then keep only numbers selected by the bit criteria for the type of rating value for which you are searching. Discard numbers which do not match the bit criteria. If you only have one number left, stop. This is the rating value for which you are searching. Otherwise, repeat the process considering the next bit to the right. The bit criteria depends on which type of rating value you want to find. To find oxygen generator rating, determine the most common value, 0 or 1, in the current bit position, and keep only numbers with that bit in that position. If 0 and 1 are equally common, keep values with a 1. To find the CO2 scrubber rating, determine the least common value in the current bit position and keep only numbers with that bit in that position. If 0 and 1 are equally common, keep values with 0. Okay. This is a bit more complicated, actually. So from our example, So we can use our gamma and our epsilon to locate our thing. We have a filter option in nim. Nim, let's see here, array filter or sequence utils, filter. Map filter x169. Okay, I think we can do this pretty straightforwardly then. I think if equal so after we find our gamma and our epsilon, this filter is a little weird. So we want the most bits. Gamma binary. Epsilon binary. We're going back to our small entry here. Two, three, four, five. Gamma binary at index. Equals 1. Epsilon binary at index is 1. Gamma binary. Epsilon binary. Let's just run that. Make sure we're getting those correctly. One zero one one zero. 10110. And epsilon is 1001. Yeah, so we're getting the string correct. Perfect. So that's easy enough. Now we have these as strings, which means we already have the values we have to filter. O2 gen which is a string, and we need CO2 scrub. Where are we at? 230? 230, not too bad. So we need to filter. We don't have a list of all the entries. We've never maintained it. So that's one more thing we have to do. Bar entries, which is a sequence of strings. Entries, not add one. Now I don't remember the syntax. We should go look that up real quick. Dot add, yeah, okay, that is correct. Which means we don't need to keep track of total entries, so we just have the length of our entries. Length of entries. I think. Okay. So a sequence of strings, well, filtered entries, length is not equal to 1. Sequence is copied. Sequence. Examples here. Var bit index equals 0. Filtered entries equals filtered entries dot filter filter. Where's my filter? I could swear I had a tab open for that. Oh, there it is. Filter. Arrow. Okay. If we set 0, we basically do the same thing, except we don't have to redeclare these. Instead of checking against gamma, we check against epsilon. And this is the CO2 scrubber. O2 generator. Gets O2 gen. The CO2 scrubber gets the CO2 scrub value. See how that goes. Filter. Sequence utils. That sure looked like the example for filter I saw. Maybe do filter it. Index. Oh, bit index. Filtered entries. Oops. That doesn't make any sense where we put those parentheses. Okay. So in theory, that's the O2 generator. One zero one one one. Nope. CO2 scrubber. 01010. So that's correct. Let's write a procedure here real quick. Let's see, what's it called? Proc. Procedures. Procedure, then a name. Fuck them name. Bin to int, and it will take a bin as a string and return an int. This equals basically this. Sort of. For C in bin, if C equals 1, zero, result plus equals that. Otherwise, we can literally say result plus equals result times 2 plus equals 1, return result. I don't have to declare result, it's just a thing. Is result an actual keyword? The procedure returns value the procedure body can access an implicitly declared variable named result. Okay, so I don't have to declare it at all. We're just done. I think. We do this. We do that. Gamma and epsilon are just equal to into int of gamma as binary and epsilon as binary. Invalid indentation, line 7. Oh. Okay. 22, 9, 188. Our O2 generator is wrong, but our scrubber is right. our O2 gen equals bin to int of O2 gen as a binary. Something down here. CO2 scrub. There we go. O2 gen. Scrub. Um, life support rating. Life support, which is O2 gen. Times CO2 scrub. Life support 220 is definitely wrong. This should be 23. It should be 230 if I remember from the prompt. 230. So something in here is filtering wrong. I feel like we're really close on this one. The longer ones we'll need later, but it doesn't really matter. Hmm. Something in this filtering is not right. I'm going to pause here for a brief restroom break. And we'll be right back. Just a minute. Okay, now we are still not sure why this filtering is wrong. Although it may be this algorithm which is wrong. And we just happened to be right enough. Third is 0. Yeah, we just simplify and not use variable at all. $220. You're still getting the same dadgum number. Okay, something is not working the way I expect. Find oxygen generator rating, determine the most common value in the current bit position. Keep all the numbers with that bit in that position. If 0 and 1 are equally common, keep values with a 1. Least common value. Keep all the numbers with that bit in the position. If 0 and 1 are equally common, keep values with a 0. Oh, I see. I think I see. Each bit of the gamma rate can be determined by finding the most common bit in the corresponding position. There are no considering the first bit. Most common value in the current bit position. Keep only numbers with that bit in that position. equally common to both. So, right. So that's to do with this caveat. That's what's killing us. One. Target value equals so we can't use the gamma bit itself. Var var where V is actually entries. Oh, one entries here. One entries at bit index. Nope. I'm just getting wrong values here. $22 should be 23. It counts. 757. Our epsilon and our gamma are fine. Our power is correct. It's this thing. This is what's not winning, not working. It should say 23. Unless, is there one that's... or was zeros. So we keep those numbers. In the second bit, there are more zeros, so we only keep the 4 numbers with a 0. In the third position, 3 of the 4 numbers have a 1. Oh, of the remaining, so not over the total. Oh dear. Okay, I get it now. I know it's wrong. I did not think through that problem correctly at all. Okay. Bit index entries. 1 entries don't count anymore. Yeah, so they built up the problem a little differently. Of the remaining values, we take the most or least significant. Okay. All right. Make a procedure. Count ones in a binary string at index integer, returning an int. Equals 0. This is a sequence of strings. If bin at index equals a 1, result is incremented. We don't have to return result, it's implied, so it's fine. I'm not sure if I approve of implicit result being declared. Written, what's range? Range, let's see, range. Range-based for loops. See here. Or n in something dot dot something. Okay. Through the length of entries sub 0. Are these inclusive? Okay. Dot dot less than length. And one entries at index equals count ones. I think I want one entries. Count ones in entries at index. Just a moment. Okay. If one's greater than length of entries minus ones, if ones is less than, that is epsilon b. So we'll check and see how that compares to what we had before. Oh. Let's just comment these two out for now. What do I do? This is a compile. What was that? F6 or something? Echo. Or what? There we go. So that's still working. Okay. Now, starting with a string. Filtered entries equals entries. We're going to walk through our index. We're going to compute one count. Oop, oh, oh, oh. That one's in our filtered entries. That's where we got the difference, really. Ones is greater than the length of filtered entries minus ones, then target value equals this thing. We're going to get a 1, else we get a 0. Those two things. I think that's that. Which means a lot of this is very similar, except index 49, 45. Bit index. I need to train myself to use the F6 key here. Okay. Hey, there's our 23, although the CO2 scrub is wrong. There it is, 230. Okay, phew. Finally. All right, I think we do this. Bit counts don't count anymore. Get these longer strings. All right, let's go plug this in. That was, I don't know if that was more painful or less painful than last. We just had the structure of the problem wrong. We got the right answer. We completed day 3. Cool, cool. Day 4. Oh, cool. We get a giant squid. Giant squid problems. We don't want giant squid problems here. All right, let's go put this into a new prompt. Wow, fingers on home though here. Prompt text. All right. We're 1.5 kilometers below the surface of the ocean. Yeah, almost a mile. 1.609 kilometers per mile. Already so deep you can't see any sunlight. What you see, however, is a giant squid that's attached itself to the outside of your submarine. Maybe it wants to play bingo. Bingo is played on a set of boards, each consisting of a 5x5 grid of numbers. Numbers are chosen at random. Chosen number is marked on all boards on which it appears. Numbers may not appear on all boards. If all numbers in any row or any column of a board are marked, we don't do diagonals. Good. The submarine has a bingo subsystem to help passengers. Currently, you and the giant squid pass the time. It automatically generates a random order in which to draw numbers in a random set of boards. For example, here's our numbers, here's our boards. After the first 5 numbers are drawn, there are no winners, but the boards are marked as follows. Don't see any marks. There are still no winners. Finally, 24 is drawn. Before 17, okay. The score of the winning board cannot be calculated. Start by finding the sum of all unmarked numbers on that board. Okay. Thanks. Okay. Finding the sum of all unmarked numbers on that board. In this case, the sum is 188. Then multiply that sum by the number that was just called when the board won to get the final score. Okay. Unbelievable. That's stupid. 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 What the heck? Oh. This must be people begging for money. Mail. Okay, so we're going to play bingo to guarantee victory against the giant squid. Figure out which board will win first. What will their final score be if you choose that board? Oh my gosh. Junk mail. All junk mail. Okay. So, if this is our small input, Now I'm curious, what does our actual input look like? Get my inputs out of here. Don't. Oh, they're all still 5x5 boards. So we have a pretty straightforward way to read boards in. Which board and the score? So a board is a 5x5 of a value and a mark, whether it's been marked or not. It is probably worth it. Let's see here. Let me see. Nim to the array. There's something like this. Ready? Our rows are 5, our columns are 5. Our type, we get a row, which is an array of columns. I'm making these caps. A row number of rows. A B is a board. Except we're not going to call those ints. We're going to declare a cell to be a tuple. We got to go back and look at tuples. Do I even remember how this all works? Documentation. Tuples look like this equals a tuple whose value is string. No, it's not. It's int, and its state is bool. Yep. Okay. Procedure. Init a reference to a board. Which equals index in 0 to my preference columns to column count. Board at row and column equals a tuple where value equals parentheses. You can just do it positionally. 0 and false. We should be able to initialize a board. We're going to make a couple of helper functions here. Proc print board. For each row, for each column. How do I want to indicate if a cell is marked? With a plus, maybe? Board at row, column, dot state. Echo. There's probably not a good way to echo a fixed width thing in nim, is there? Nim, how to add print added string. str format. Okay. Out of my curiosity here. Input. Don't do this one anymore. Input. Nothing bigger than 2 digits. Good. So let's get string format. Let's see your format. No. Formatting strings. Colon. It's then 4. Row. Column value. Colon less than 3. Except we want the value. What we want is X. MT. With parens. This is probably the most readable for me. And then at the end of the row, echo, let's see here. Nim echo, no new line. Standard out dot right. std out dot right. Echo, nothing. You get the new line character. Let's say var b equal is a board. If we init b, what's that going to do? Int bool for 0 false, but expected int. Really? Oh, agreed. Type mismatch. Board B and it B. Expected one of a reference. Let's see here. We just have to look up nim syntax. Oh my gosh, I have so many tabs open. So many tabs. Let's see. Class reference. Blah 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 procedure. X blah blah blah. HTTP reference. It's not as helpful. Let's see. Surely. Procedures. Result variable. Parameters. Discard. Named arguments. Default values. Overloaded procedures. Okay, cool. Operators. Iterators. Okay, let's see here. Ref. Not sure that's actually helpful. I have to. No, let's just see. There are things about NIM I'm not 100% clear on, including posing more complex data types. Variable. I'm not sure that their error message is as helpful as it could be. Init B, 1B, expected one of first mismatch at position, word ref board. Him, how to pass a ref. I just say ref. Is that it? Is that all I have to do? A reference to board and a reference to board. Main line 29. Reference to B is a reference to a board. Illegal storage access attempted to read from nil. Okay, so I have to initialize my board equals something. Maybe then this just returns a reference to a board. No, let's just pass it the board. Board. I make a board. It makes an array of rows, which makes which may not be filled. So for each row, our row equals a new row. That equals that, which creates a new tuple of cell. Hot ref row for a new row, but expected row equals cell. We can do that. Hot ref board for new board, but expected board equals array of rows. Type expected RB is a board. Undeclared identifier init. That's fair. Type expected on line 30. Type expected line 30. Type is expected here. Shouldn't the type inferencing figure it out line 30. I'm sure this is frustrating to people who know NIM. A cell is a tuple of integer and value. A row has a column count worth of cells. Considering it, here's our board. We just go through. We don't have to make a new row. For each row, for each column, we set it to 0 and unmarked. Print a board. I don't think this should be so hard. Type expected on 29. The error message is not helpful here. Yeah. Type expected. Hey, how to get a reference to a variable. The dereference is square brackets. And by example references, new. Person ref. I'm a little confused here. To create a reference, use the new procedure.
Show every day. You are.
A declarative and assigned variable of reference type will hold nil. To create a reference, use the new procedure. Will be zero valued. When required, a reference can be referenced with blah. Trying to dereference a nil will cause a crash. Use is nil procedure to check if the reference points to a valid value. An object type can be defined as reference based by declaring it as whatever. When accessing object fields, dereferencing is not required. Oh, interesting. Since the type is reference based, reset will not make a object. So maybe I just do something like this. Board ref equals a ref object. A reference to a board. Therefore, var b equals new board ref. I have a board. That's not a reference. How do I get a reference to an existing object? Ref, person ref. Equals new board ref of board B. confused here. This match got board for B, but expected board ref equals ref board. Okay, oh, no. They printed something out. B is declared but not used. Blah, blah, blah. Set value your board at row, column, value, board. Row, column equals value. Mark and clear. B dot set value. Oh, sorry. Of B at 0, 0 to 13. B dot mark or mark B at row 0, column 1. Line 30. Three. Okay, so it doesn't take this, so whatever the internet said is wrong. Word row column dot state. $13 and that was X'd out. So okay, that's sort of working, but the print is garbage. Does this work? Invalid indentation. All right, shoot. Then print to console with no new line. How to print without it skipping a line in nim. Use echo and not print to a line. STD outright. You should use STD outright. And I did that. STD outright. Let's see. How do I rank nim now? It's not bad. I don't know if I would want to work in it every day. It's a little bit. It's got that interesting crossover of Python and C. It's strongly typed, but I'm not typing nearly as many brackets and things, and it's all white space sensitive. But like it's got a lot of built-in string support and so forth, which isn't bad. Where's the most important thing you want to have in your system level coding language? Right now, it's not. My system level coding language is not clearly defined because I want to try things. I want it to experiment, I guess. I want to try different syntax, different control structures. I don't really care. Like, I don't have a religious zealot belief in something a language has to have, or that I want to have specifically. I want to try things, and if it makes me happy, I'll keep it in. So I guess the key feature is I want to use a language that makes me happy. And that's subjective. It's not clearly defined. I just want to play with concepts and see how it works. I don't know if that helps. I imagine the first one did this. I thought the first one, the first language you make, isn't going to be great. I've already changed that text. Invalid indentation. Still isn't outputting without the new line. Why is it putting new lines in? STD out not right. I'm going to start at input here. Come on. So that's interesting. Like I have to declare a reference to a board and instantiate it, but I can't take a reference to a board that exists not with the new keyword. So basically, you're forced to make references on the heap and not reference material on the stack, which is an interesting line to take, unless there's something I'm missing, which is possible, but a little confusing. Yeah, right. Oh, this echo is in the wrong place. That's the problem. That's a board. That looks better. Good, good, much better. Phew. Okay. What is the concept of tryout from the languages you've tried the last couple of weeks? Oh, yeah. So there's some good ones. In fact, I think on Friday at the end of the day, we're going to go through all that stuff. But Odin had some interesting ideas. Let's see here. Odin Lang. I don't remember. See more examples. No. Docs. Getting started. Let's see here. Nope, not getting started. Overview. All right. Don't like a lot of this. Okay. We are definitely doing multi-line nested block comments. We're actually gonna do some crazy stuff with that later. This is also in NIM, and I think Zig does as well, which is good. So we're gonna do that. String and character literals. So he's going through types here. I'm not really that interested in types at this point. Packages, I don't like the way he's doing packages to some degree. He's decided that everything needs to be a for loop, which I don't agree with. So we'll come back to that. I definitely want defer. So do some code when you exit the current scope is good. Let's see, reverse iteration. Switch statements. I have some ideas around switch statements that are not related to this. Partial switch, defer statement, when statement. I don't want to do when statement. I want compiler directives to be very clear. So like it'll be pound if it's a compile time if statement. I don't like the when, which is the same thing in NIM. Let's see, let's take a look. What else? Break. Yes. So, and this is not something I got from Odin or something else. I want named for loops with breaking out of named for loops. Not Odin specific, but it is in Odin. I'm going to steal that anyways. Continue. Again, you can continue a named loop. That will be a thing we can do. I don't like the syntax for switch or case in almost any language I've used, so we'll fix that. Procedures. Okay, so one thing I am stealing, well, and again, I didn't see it in Odin first, but multiple return values. I should be able to return multiple return values. I do like you can name your return params here, and they're just automatically, so this result is an integer, and you can just use it right away in your computation without declaring it, because you declared it in your function declaration. So I like that. In NIM, this is implied, the result variable. So I like this thing. I can declare that it returns an x and a y, and I have those x, y's to be used. Multiple results, yes, exactly. So here's your x, y as an integer. Good stuff. I like that. I'm gonna steal that for sure. Named arguments, that's not Odin specific. Default values is not Odin specific. I don't like this. We're gonna do something different. Basic types, 0 values. Type conversions. Yeah, I don't know. There's so many different type conversions and things. What's the best way? Transmute. I'm not sure how I feel about the transmute operator. We'll think about it. Autocast. Built-in constant spell procedures, blah, 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 blah. Strings. Yeah. I don't know. We're going to steal some things from Odin. Let's look at Ziglang. That's what I like about Ziglang. Like, this is the one thing that's just amazing. Okay, compile time execution. Good idea. I like it. No hidden control flow. Where was there? No, learn documentation. Language reference. Yeah, this one. Okay. So from Zig, the best thing about it is that I had to install no dependencies. It had no dependencies on my system at all. Everything was there. I unzipped it, set my path variable, and was done. Just worked. And from within that, I can now build for Mac, Linux, Windows, all of the architectures from Zig with no problems. That's great. That is amazing. The compile experience with Zig is 100% excellent. I'm trying to think, what else would I steal from Zig? Um, la la la. Let's see. Oh, so have this idea of tests being built in. I need you. There's, and this is the thing I want language to address. There's sort of two schools of thought, and I can see from both of them. One is you put all of your tests in line with your code. So when you declare a function, you also put a test next to it. And that way, when you modify your code, you're already right next to the test. Another one is you don't want to clutter your code. So you want the test code to be in a separate file, but then if you modify your code, your test code is in another file. So like cluttering your main file versus keeping your test code up to date with your main code. I have ideas for fixing that is not here, but having basically your tests accessible from within your actual source code file, that's a feature I like. And that's also in Python. Like all of these things are in other languages as well. Testing namespace variables identifiers. Trying to think here. Zig does have built-in what's it called? Optional types or maybe types, depending on what language you're in. Static, local, thread, local variables, integers, floats. Like Zig gives you a lot of control over your local memory. It's very very good that way. Um, Arrays, vectors. Okay, I actually really like the Zig syntax for dereferencing a pointer, I think. I like that you specify if it's a pointer to a single element or to an array of elements. Having a slightly different syntax is really good because then I don't look at something like, oh, that's a pointer. Well, is it to an array or to a single element? The slicing for both Odin and Zig were good. I like the slicing. I mean, again, it's also in Python. Slicing, compile time pointers. Yeah, the fact that you can do so many things at compile time is very powerful. Yeah, we're gonna go through a lot of this stuff and steal wildly when we go to make our own language. I've already got the name for the language figured out, so that's good. That's usually the hardest part. Blah, blah, blah. Yeah, this is just such a huge document. There's no way I'm getting through it today. Yeah, those are some things that I like. What a long document, jeez. Okay. Yeah, so we're gonna steal a bunch of different things from all over the place, plus some unique ideas of our own. Okay. Init B, we need to load a board or create a board, which means we need to actually start reading our file. var first equals true. If first equals false. And this line is our moves, right? Moves is a sequence of integers. And then boards is a sequence of board ref. I think that's the right way to do it. If it's first equals false, split. We have examples of this in old ones. Main O2 main split, yes. Our entry in split our line on commas. So we're going to split this on commas. We're going to take moves dot, I don't remember, add or append. Add. Did I use a sequence here? Yeah, add. Okay. Add parse int. Jeez, come on. Stop this nonsense. Of the entry. If it's the first non-blank line, those are our moves. Otherwise, we need to parse out a board. So hold on just a second. I'm going to do the following. I'm going to take a quick restroom break. We're going to parse out that board in a minute. Just a minute. Be right back. Okay. And back. Okay. I like the idea of top level declarations don't have to be in a particular order. That's always nice. Okay, let's see here. Var row count equals 0. Otherwise, if row count equals 5, row count equals 0, var b equals new board, init b sequence, let's see, boards dot add b. So basically we create, if we're at row count 5, we create a new board and add it. We set a row count. Then for entry in split line on spaces, I'll take the last board. Where's my last board? Nim. Oh, let's see, we can just do this. Var b equals boards at when boards -1 b sub, let's see here. For column in range. In 0 to column count. B at row count column equals parse int of entry. Is that it? And then at the end of the row, increment row count. Yeah, this is probably easier to read. Okay, then for b in boards, print b with a new line. Okay, and declared the entire moves. Thought we did that. Whoops. Wrong number of variables. 58. I'm not sure we really need clear. Imported and not used sequence utils. Huh. Mark, blah, blah, blah. Invalid integer is not handled. Mainline 60. All right, Nim. Nim parse int error. All right, I guess it's not going to help me there, so we're going to echo entry. Twenty-two, 13, 17, 11. Splitting on is okay. All right, we can still work with this. If entry not equal to empty, I think that should work. There's our 3 boards. Turn it out just the way we want. Perfect. Okay, so we're reading them in. Blah, blah, blah. Now we need to execute the moves. Oh, we need to ask one more question. Proc has win. Board, reference to board. Let's return a Boolean. For each row, let's see here. Does nim have named loop structures? That would be nice. Nim labeled loops. For loops and iterators. See, this would be amazing. I would really like labeled loops. I don't know why people never do it. So like I said, some of these things are in multiple languages, but okay. first we're just going to go walk through each row if the column is all marked. If board at row and column dot state equals false, break. If result, break. So what this does is it says, go through each row and assume the row is passing. Go through each column in the row, and if we find one that isn't, we can even make it a little easier to, no, it's fine. Maybe not. If we have one that isn't marked, then our result is false when we break out of that row. If the result is true, that means we waited all the way to the end of the row and did not break out, so we can break out and say, yeah, we did have a win. If the result is not done, then we do all of this. But columns first, then row. So if everything in a column is valid, it'll break out and be done. Return the result. Do we have a win? Print. Okay, let's see. Then the scoring is a little bit weird. Prompt, we need to look that up again. At this point, the third board wins because it has at least one row or column marked. The entire top row is marked. The score of the winning board can now be calculated. Start by finding the sum of all unmarked numbers on that board, then multiplied by the number that was just called. Okay, so we're going to do something called score. Proc score board reference to a board. It'll be an integer. Result plus equal if board row column dot state board, let's see here, result plus equals board at row column value. That's basically it, right? I think we might be ready to simulate the game. For move in moves, for board in boards, board dot mark mark. Oh, proc mark value for row for column forward at row, column value equals value, forward mark at forward row column. Forward dot mark value move if forward dot has a wing. I don't know why I keep doing this. If the board has a wing, score equals score the board print the board and echo winner which is the winning score times the move equals winning score times the move break. Done equals false. Done equals true. Break. If done. Break. Okay, let's see if that works. I'm gonna run this against our small input. Invalid indentation on 49. $107 invalid indentation. Forward. So does this match what the prompt said? 4512 is correct. 188 by 24. Okay, so we should be able to play against the whole thing then. Against the larger data set. Didn't crash. Alright, there's our winner. Let's try it out. Let's go submit that on the board. Paste. Submit. Hey, it's the right answer on the first try. Good job. Part 2. On the other hand, it might be wise to try a different strategy. Let the giant squid win. Great Star Wars reference. Excellent. From the good Star Wars, before Star Wars went bad, before the dark times. Move forward. You aren't sure how many bingo boards a giant squid could play at once. So rather than waste time counting its arms, the safe thing to do is to figure out which board will win last and choose that one. That way, no matter which board it picks, it will win for sure. In the above example, the second board is the last to win, which happens after 13 is eventually called and its middle column is completely marked. If you were to keep playing until this point, the second board would have a sum of unmarked numbers equal to whatever. Figure out which board will win last. Okay, that's a nice little variation. Let's extend our board just a little bit. A board part 1. We could do something more computationally efficient. But I don't know if it's worth it. Sequence. We need to be able to remove at sequence. Remove element from sequence. Just dot delete. Okay. Bar first win is false. If first win hit the board, first winner and first win equals true. We've had one. We no longer break. If this board has a win, variable indices to remove a sequence of integers. Indices to remove dot add index. Length of indices to remove is greater than 0. Let's see here. Nim. Reverse for sequence. Sequence utils modules. Reverse. Nim sequence reverse. Does a nim replace? Let's see here. Nim range reverse. For loop in reverse order for I equals intent down to 1. Oh wow. They did have negative indexes though, right? Index in indices to remove. Zero, 2, length of indices to remove. var2 remove. With indices to remove. At. I think this is it. Basically, let's walk over indices in reverse. I think this will do it. Then we go to boards, delete that to move index. If length of boards equals 1, we need to do a bunch of other stuff. Length of boards break. Length of boards equals 1. Let's do this against input small. On line 98, invalid type. Indices to remove. Unhandled exception, index 1 not in 0 to 0. 1, 4. One, 6. Oh, clear sequence. Yeah, clear sequence. Set len 0. We check this. Indices to remove. A little bit puzzled by this. Pretty sure I've played all the usual tricks here. Indices to remove. This didn't help at all. Oops, let's see here, F6. There we go. First win, just like we expected, that's winner. Is this number, which we submit somewhere over here. Boom, it's not the right answer. Return to day 4. Oh, well, that's not the answer. It's what we need to compare against our small input. That's what's wrong here. So 1924 should be what the prompt is expecting. 148 by 13. 1924, that is correct. Okay. Now I run it against the main input. Now we submit it. That's what we meant. Oh, I have to wait. 4 seconds left to wait. Hey, we did it. We completed day 4. Nice. 5 o'clock. Oh. Honestly, NIM so far, we've cranked through probably the fastest. Its similarity with Python means we can move pretty quick about certain things. Yeah. So let's write down some first impressions, I guess. Notes for NIM. Advent of code. First day, cranked out 4 puzzles. We did 2021. Overall, pretty easy to use. Similar in syntax to Python in some ways. String handling, it's fine. Ref versus a thing on the stack is a little strange. I'm wondering if I go back and look at the Zig for C. That might tell me more usefully what a pointer needs to behave like. Oh, okay, so we could have done this differently. Okay, I see what we could have done. Let's go do that. Some places uses keywords where an operator would normally go. Think instead of plus. Pointers, bins, what we could have done. Are you ready? If we want references. This is not quite what we want. Just put it there it was. Ref board ref. No, I don't want this at all. Board ref. But what we could have done, are you ready for this? We need it clear. We could have declared, so here's what we were doing. We said B is a board. Then we said board reference is a reference to board, and we just wanted a pointer to what's in B. But what we could do is this is how you get the address of a board. That's what we could have done. But then the fact that dereferencing board 2 is a board equals board reference. This is how you dereference, which I do not like. Use ref and address. Deref a pointer is not consistent with declaring a pointer or getting an address because it is pointer subscript. This doesn't make any sense. I don't really like that part. Ranges aren't bad. Ranges are fine. We haven't had to slice. But yeah, overall, not too bad. May also be the nature of the puzzles we're doing. Some of them are pretty easy. So yeah, 5:15. We've got. We could go a little longer if we wanted to. Let me think. Okay. So overall, NIM, reasonably positive experience. I think if I had to, I could use any one of them. Odin, Zig, NIM. Where would I put NIM? Without doing any performance measurements, I would probably put NIM above Zig for myself. I like Zig is just, there's a few things about Zig that just kind of get under my skin, a little bit under the old fingernails. I didn't see any crazy features in NIM that I want to have. This isn't strange, just the syntax, if you kind of mentioned these next two. Blah, blah, blah. Okay, so Overall, not bad. My favorite puzzles have been in the 2019. So maybe we just use a Python and crank through as fast as we can. So we can finish up 2019, or do we stick with Odin? Because we've already written our virtual machine in there. The lack of Emacs mode makes me sad. Transpile to C. I plan on doing it in a toy language or in our language as a teaching moment, right? Here's how you would do this, and translate your ideas into C. But I don't think I would ever actually use it in a real project. So the fact that Nim does is a little bit odd to me. You have to turn your ideas, your language constructs into valid C. I'm just curious, what else is in here? If we go to C4. I don't know where Nim actually puts the C. Let's go Google that. Nim, where can I see the C that Nim outputs? Nim cache project name. Let's go see if we can take a look at that. Main.json, I guess, at main nim c. Nim integer bits, language C. I mean, how big is this? 1,000 lines? Nim call, static inline, nim frame. See, I don't find this particularly human readable at all. The word board doesn't even exist here. Boards. I don't find this particularly readable. What are the strings? First winner. So what's it doing? Declaring our string constants. Last winner. Const structure, nim character data 13 plus 1. 14 plus 1, yeah. So there's all our string constants. So that's not even within the context of our code. Like literally, this code that it outputs is not human readable. It bears very little mapping between what I wrote. Lots of go-tos. Again, I'm not afraid of go-tos, but like this is not readable. You get lovely nim integer probably with generated names that aren't usable. I can see that this would be faster than just writing it myself in C. Thousand lines of code. To be fair, things like split was quite nice. Yeah, it wraps everything in go-tos and whatnot. Interesting. Yeah, there's not a clean mapping between the nim code you write and the C that nim outputs. That's transpile. There's almost no way to humanly debug what nim outputs. You are very reliant on nim, despite the fact that it transpiles to C. Interesting. All right, we're probably going to call it there for the day. We'll do a little bit more. We need to do a little more nim. Do we do some Odin tomorrow? I don't know. We'll take one last easy day tomorrow, and then we actually need to talk about the shape of the stream for the rest of the year. I think things are going to have to change a little bit. But yeah, thanks for joining me while we explore some nim programming. It's an interesting little language. I'll have to keep it in my back pocket. All right, well, thanks for joining me. Have a wonderful evening, and I'll see you tomorrow. Bye-bye.